Thanks, everybody. This work is joint with Gi-chan Kim, who's a PhD student of mine at Ohio State University, and David Guarana, who's a soil scientist with CIMMYT. He'd previously been at CIMMYT Nepal here in Kathmandu, and now he's actually at CIMMYT in Mexico, but still sort of in touch with a lot of the people here in Nepal. So, we're going to look at this relationship between soils and South Asian stunting, and specifically this is situated in Nepal, but I think the implications are wider even for at least other areas of the Indo-Gangetic Plain and some other areas of South Asia. So I'll sort of motivate both with talking about South Asia generally, but then specifically what we're really thinking about is Nepal. So I think everybody knows here that South Asia is the worst hotspot for malnutrition in the world as a sort of region, and this is despite growing income, right? So very high in Africa too, but here income is going up, and malnutrition doesn't seem to be going down as we would expect. And zinc deficiency specifically, as Dr. Reddy and also Dr. Bui mentioned, is really widespread, along with iron deficiency. So zinc deficiency is important because it drives skeletal growth in children. So the primary clinical outcome for zinc deficiency is generally expected to be stunting. It relates to all manner of morbidity in children, various types of diseases, also in adults, cancers. It relates to child mortality. It relates to cognitive development too. So zinc deficiency is important for a myriad reasons for health and cognitive development. 40 to 60% of children or women are zinc deficient in India, Pakistan, Sri Lanka, and Nepal. And the recent national micronutrient survey that was done by the government here found that 21% of children were under 5 were zinc deficient. And that's really varying across the country. So it's much less in the central region. It's very high, about 30% in the most isolated far west areas of Nepal, the 2 western development regions. And so the question is sort of why is zinc deficiency so rampant? And of course there's many answers, so I'm only going to talk about one of those things. Lack of animal source foods is really important, as the last speaker talked about. As Dr. Bui mentioned, high pulse prices and low pulse production has been related in India to low micronutrient intake. Probably that's true in Nepal too. And so there's many reasons. Also, sort of the nutrient concentration of crops is going down as carbon levels in the soil go up. But what I'm going to look at is the relationship between soil zinc deficiency and crop zinc concentration and how that has impacts for human health. So there's 2 ways in which, and I've sort of bulleted each of those, soil zinc deficiency relates to human zinc deficiency and human health. The first is that soils with low zinc concentration, crops just don't grow as well. The yield is less. So if you have low crop yields, then you just aren't growing as many calories, you don't have as much agricultural income, and so families growing these sort of like stunted crops may not be able to get enough calories, get the sort of proper dietary diversity. And that's really an important pathway. The second pathway is that when you grow crops in a low zinc soil environment, the crops themselves have lower zinc levels in the edible portion of the crops. So both pathways have been found in the Indo-Gangetic Plain. Most of this work has been done in India. So there's a number of soil scientists that have found in India, particularly in northern India, that when you grow rice and wheat, sometimes other crops, that if you grow them in zinc-deficient soils, the yields are lower and also the crops will be lower themselves in measured zinc concentration. CIMMYT has done a little bit of work here in Nepal on this, and they're still analyzing the data to see whether this is the same, but they sort of expect that it'll be the same because the soils are quite similar in the Terai as they are, of course, across the border in India. So there's suggestive evidence in other places also linking soil zinc or selenium deficiency to human zinc and selenium deficiency. So this is not an idea that we, David and Gi-chan and I came up with, right? This is an idea that crop and soil scientists have been talking about for a while, and we just thought, well, we have a unique ability to really look at this in the context of Nepal because of the data that we have here. So the data that we have is we have these soil maps for the Terai. This was based on thousands and thousands of soil samples taken across the Terai by the government here, and using very highly accurate mapping algorithms created by Hingle et al., done by CIMMYT to create these very high resolution maps. So you can see like the top of soil extractable zinc, pH, sand. So we have these very good soil maps all across the Terai, very accurate. And what we're doing is we're trying to say, all right, like we don't want to just totally pick up a spatial correlation between zinc deficiency in human and zinc deficiency in soil. Instead, we're really going to try to look at sort of within development regions. We'll hold development region content, look within, and then we'll try to partial out many other things that are related. So we're going to hold constant other types of soil fertility and many other population and infrastructure type of variables, and see as zinc deficiency moves up and down in the soils separately from the regular soil fertility, specifically zinc deficiency, how does that relate to human outcomes? So we're using the Nepal Demographic and Health Survey for 2006, 2011, 2016. This doesn't have measured zinc deficiency in humans, but what it does have is child height for age and child stunting. And of course, we know that child height for age and stunting are highly related to zinc deficiency. So we're going to see whether it looks like the zinc deficiency in the soils is related to child height for age and stunting, which would be indicative, it doesn't prove, but it would be indicative of a relationship between soil zinc deficiency and human zinc deficiency. And you can see these are sort of scattered, these three surveys are scattered all around the Terai and the hills, but we're only going to be looking at the Terai because that's where we have these soil maps. In the future, we may also have these soil maps for the hills. We can extend that analysis, but right now we have soil maps only in the Terai, which is probably the most important to look at for this area, right? Because that's where the majority of the crops are being produced. We're also using nightlights data to look at a proxy for sort of economic integration. So we have nightlights across Nepal for 2006, 11, 16. We have precipitation and weather data that come from the European Center for Medium Range Weather Forecasting. We also have population data over these three relevant years, and a few other types of data. So this is sort of just a general summary, and I won't dwell on this because I think people in this room are really familiar with these statistics. But you can see that, of course, stunting is very high and is going down over time, but it's still remaining very high. Wasting still very high, even though it's going down a bit over time. And anemia, and that's for children specifically. So what we're looking at here is we have a data set with one observation for every child. So we're going to analyze the impacts of these soil characteristics on children using sort of all the children pooled across the three DHS, Nepal Demographic and Survey data sets. So the first thing that we're going to do, you can sort of ignore this math if you want. The first thing we're going to do is just try to look at the average effect, right? What's the average relationship between soil zinc deficiency and human stunting and other health outcomes? And second, we're going to say, all right, well, what we expect is that it wouldn't, the effect of soil zinc deficiency wouldn't be the same for everybody. If you're living in Kathmandu and you mostly eat foods that you bought from the market, and those foods could have been brought in from China and, like all over, then maybe your local zinc deficiency right here in Kathmandu probably isn't affecting how much zinc you're eating, right? Like for people living in the city, the zinc in the soils under our house don't really relate to the zinc that we're eating. And similarly, in places that are sort of just close to a city or have a lot of market access in other areas of Nepal, where you really expect to get a strong relationship between soils and humans is in the places where you're a bit isolated and people are really relying on the local agricultural production. And so we'll kind of try to test whether that holds true in the data. So the first result here is looking at the relationship between extractable zinc or available zinc. We get the same thing basically with both of these measures. The relationship between these zinc in soils and height for age in children. So you can see that if you move up 1 part per million of extractable zinc or available zinc, and that is sort of akin to going from like the 10th or 15th percentile in Nepal to like the 90th or 95th. So you can think of this as a change of going from the lowest soil zinc concentration in Nepal to going to the highest zinc concentration. Not the very, very highest, but the sort of highest, lowest brackets. So if you move from this low bracket to high bracket zinc deficiency in the soils, what you find is that height for age is increasing about 0.12 or 0.13 or even 0.14 standard deviations. And I'll talk more about that effect size later at the end. Stunting is going down like 4 or 5%. So that's a 4 or 5% difference in child stunting from the low to the high zinc areas. And severe stunting also goes down like 2 or 3%. And then we looked at other health outcomes, what a lot of nutrition scientists, and again, I'm an economist actually, I focus on nutrition, I read a lot about nutrition, but some things, I rely on nutrition scientists to tell me. So what a lot of nutrition scientists are saying now is that even anemia in South Asia is not only driven by iron deficiency, but also sometimes driven by a zinc deficiency. And then in our data, what we find is that anemia also is going down as you increase zinc concentration in the soil. So from the low zinc to the high zinc areas, you have a difference of about 9% of anemia in the Terai. It doesn't seem to have a very strong relationship with other outcomes, which is sort of what we expected. Low birth weight, wasting, diarrhea, fever. You do have a minorly significant relationship between acute respiratory systems and soil zinc concentration. You note, though, that it's always negative, right? So you always have this steady sort of people are a tiny bit worse off in these other health metrics as you move from the soils that are low in zinc to the soils that are high, but not nearly as strong as what you see for child growth. And that makes sense because zinc deficiency can impact many other things, but the strongest indicator of human zinc deficiency is child height for age, how children are growing. Similarly, if we look at other outcomes for the household, that's the second table, you find that there's sort of minor relationships between household welfare, but not really strong and not statistically significant, where the stars here are the ones denoting statistical significance. So then we do something where we try to say, like, well, what are the mechanisms that are underlying that? Is it income? Is it food deficits? When I won't take time really to explain the methodology, but basically what these bars are saying is that even if you account for income, you get the same effect. It doesn't really seem that it's working through the income. And actually, the Demographic and Health Survey isn't measuring income, it's measuring assets. So it's not working through the assets. Food deficit too, for 2 of the years we have this question about whether you've recently had a food deficit. It doesn't look like the relationship is working through food deficit. It doesn't change the estimations. What you do find is that if you account for mother's height, mother stunting, that's a little bit of the relationship. So part of the relationship is explained by the fact that people on lower soil zinc areas, their mothers are in fact shorter too, which makes sense because if you expect that children in that local area are gonna have lower height, then maybe also their mothers who grew up in the local area might also have slightly lower heights. So not a big part of the relationship, but a little part of the relationship. So then we look at sort of, if we estimate this, like I said, across different areas, what do we find? So the one is that we only really find a statistically significant relationship for the people who are not eating animal source foods in the recent week. So this is a question in the Demographic and Health Survey. For people who eat animal source foods, you don't see as strong of a relationship. Similarly, you see a stronger relationship for farmers, people who own arable lands and are likely to be eating locally produced crops. So that's kind of what you would expect. Of course, there might still be a relationship if you're a trader in the local area and you don't grow your own food, but you buy locally produced food, but maybe you wouldn't have it as strong, and that's sort of what we see here. Similarly, if we look at night lights in Nepal as a sort of proxy for economic integration, so as you get more and more lit up in your local area, so you're probably living closer to a city or to roads where there's a lot of trade and sort of access to foods at markets, you have a lower transmission from the soils to the humans. So the highest really is for the people who have very low night lights in the very rural, isolated areas. Similarly, we thought, this was actually a suggestion by an economist who, when I was presenting, he said, well, does the effect get stronger when you've had like really good agricultural conditions such that people in the local area have a lot of local food and you can rely heavily on your local food? You don't have to bring as much in during the lean season from other areas. And we find that yes, it really looks like when you have good agricultural conditions in the local area, which is when you would expect also people are eating the crops for longer, right, that were grown in the local area, then you have a stronger relationship between the soils and the child stunting. And that's particularly true in the areas that are isolated in the rural areas, in the low nightlight areas. That's where it's really true. So as a sort of overview, what we found is that moving from low zinc to high zinc soils, this 1 part per million shift, increases height for age by about 0.09 to 0.14 standard deviations. That's 6 to 9% of the mean height for age. So a change in the mean of 6 to 9%. It reduces stunting by 3 to 5 percentage points, which is about 9 to 14% of mean stunting in the Terai. This effect size is approximately equivalent to a trial that we read where you do two months of direct zinc supplementation. So it's not really that this would necessarily be, whether you give zinc supplementation or whether you sort of try to change people's dietary diversity or whether you try to change the nutrient concentration of cereals, these are all different ways that somebody might impact this, might impact human zinc deficiency. And we think one policy implementation, moving to the bottom here, is that you could say, well, maybe one solution would be that the fertilizers being sold in the terai should have nutrient-enriched sort of minerals, zinc, selenium, boron, potassium, higher trace minerals in the fertilizers, and this could increase human mineral intake. A lot more research needs to be done before you would say that, right? We need to do more work with other data sets. We need to do experimental trials. CIMMYT has done a little bit of that. And it's a strategy that has worked in other countries. For instance, in Finland, they had a policy where they mandated selenium enrichment of the fertilizer all across Finland in the 1980s, and selenium intake went up all across Finland. But you wouldn't know necessarily this could also work in Nepal, right? Like, a lot more work needs to be done before you can say, yes, this is a good policy solution for Nepal. All right, that's it. Thanks.